So how do you solve a partial differential equation using the method of characteristics? Suppose you have a partial differential equation, a times u sub x plus b times u sub y is equal to c, and you have the initial condition u of d and g is equal to h, where a, b, and c are functions of x, y, and u, and d, g, and h are functions of x and y. How will you proceed? The first thing you will do is parameterize your x and y with some parameters t and s. T and s. T is for time and s is I don't know. Yes. Then what you will do is you will set your a equal to dx dt, your b equal to dy dt, and your c equal to du dt. And why do you do that? I don't know, but that it worked for me in my exam, so yes, it works. The second thing you will do is you will set x of 0 and s equal to d of s, y of 0 and s equal to g of s, and u of 0 and s equal to h of s. So remember, d, g, and h are the functions in your initial condition. So now instead of having x and y as variables, you will simply have s and s as variables, given that t will be set to 0. Yes. So yeah, you have like instead of having d of xy, g of xy, and h of xy, you will have d of ts, g of ts, and h of ts. But given that we set t equal to 0, we will only have s as our variable. Yes. So just for a quick example, we will look at examples in the next few videos. But just like if you have as initial condition x of u of x0 is equal to y squared, your d of x is equal to x, your g of in fact it's d of xy, d of xy is equal to x, your g of xy is equal to 0, and your h of xy is equal to y squared. Now instead of x and y, you will have t and s, but t will be set equal to 0. So like instead of dxy is equal to x, you will have d of s is equal to s. Instead of gxy is equal to 0, you will have g of s is equal to 0. And instead of h of xy is equal to h squared, you will have simply h of s is equal to s squared. Yes. Yes, so you just replace everything with s, given that t is equal to 0. Yeah, so those will be your initial conditions, and that is dx dt is equal to a, dy dt is equal to b, du dt is equal to c. We can consider them as ordinary differential equations, because now those aren't partial differential equations, but simply ordinary differential equations. And we will use those ordinary differential equations with those initial conditions that we set here, parameterized with t and s, of course, to solve for x of t and s, y of t and s, and u of t and s. Yes, so we will simply solve this differential equation like dx dt is equal to a, so we will try to dx dt is equal to a, so this is an a here, x is equal to what, and then y is equal to what, using dy dt is equal to b, and u of t and s is equal to what, given that du dt is equal to c. And then again, you will use those initial conditions, x of 0s is equal to ds, y of 0 and s is equal to gs, and u of 0 and s is equal to hs, to find the coefficients like c sub 0, c sub 1, c sub 2, and so on. Okay, so yeah, you simply solve an ordinary differential equation. Three of them, actually. Yes. So once you have done that, once you have found your x of ts, y of ts, and u of ts, you will solve for t and s with respect to x and y. Okay, like if you have like y is equal to t and x is equal to x is equal, like I don't know, to t plus s, you know that you know that t is equal to y, and so you can replace your t in the second equation with y. You will have x is equal to y plus s, so s is equal to x minus y. Okay, x minus y. S is equal to x minus y and t is equal to y. That's how you do it. You just solve for t and s with respect to x and y. So again, why do you do that? I don't know, but it worked for me in my exam, so it could also work for your exam. If you ever find a satisfying explanation of why it works, you can post it in the comments, and that would also help me. Yeah, that would be very helpful. You can do that, but yeah, it works. I don't know why, but it works. Yes. So once you have done that, once you have solved for t and s, you will rewrite your u of t and s as u of x and y. Okay, remember that in the parameterization, u originally depended on x and y, but given that x and y are parameterized with t and s, u will also depend of t and s in the parameterization. Yes, and yes. So and once you have solved this ordinary differential equation for u of t and s, you will have obviously the parameters t and s. But now that you have solved for t and s with respect to x and y, you can substitute the t and s in the u of t and s with x and y, so that at the end you get your differential equation, now partial differential equation with respect to x and y. That's how you solve it. Yeah, so I hope that you understood a bit about how it works. I will do examples in the next few videos to make it a bit more clear. Yes, but the general overview is that you have your equation here, you parameterize your x and y with t and s, you set the coefficient, which is actually a function of x, y, and u, the coefficient in front of the u sub x, you set it equal to dx dt, the coefficient in front of the u sub y, you set it equal to dy dt, and the c, so the stuff on the other side, you set it equal to du dt. And then as initial conditions, you have x of 0s is equal to ds, where ds is the parameter in the first place of the function, is actually it's the variable in the first variable in the initial condition. Like I said, like if you have u of x and y, that will be your d, that will be your g, and that will be your h. Yeah, you have x of 0s is equal to ds, y of 0s is equal to g of s, and u of 0 and s is equal to h of s. Those will be your initial conditions. And then you have three ordinary differential equations. You solve for each of them using, as I said, the initial conditions to find the coefficients, c sub 0, c sub 1, c sub 2, whatever. And then you have your three ordinary differential equations. And then you use them to solve for t and s with respect to x and y. Yes, you write t and s with x and y as parameters. And then, given that your u was parameterized with t and s, you will now replace this t and s with the x and y. And so you will get your final answer. You will get u of x and y is equal to something, and that will be the solution to your partial differential equation at the beginning. So I hope it makes sense. Again, why do we proceed like that? I don't know. I never figured it out. I hope I will do one day, but for now it just works if you apply it. And yes, it just works. And that's how I passed my exam, even if I didn't know the intuition behind it. But still, if you ever find out the way, you can post it in the comments. That would also help me. That would be very nice. Yes. So yeah, thanks for watching.